Hello everyone, good evening. Welcome back to my channel Civil Zest. Today we will discuss a topic about the soil mechanics and foundation engineering. Soil mechanics and foundation engineering. We will discuss that basically what is soil, what is the definition of soil, and what are the types of the soil. So it is a basic topic of soil mechanics and foundation engineering. So let's start. I have written here the two definitions of soil. First of all, first definition is a mixture of organic matter and disintegrated rock is known as soil. So basically, organic matter and disintegrated rock means weathered rock or dismantled rock or destructured rock is, you can say that all these are the disintegrated rock. These are the definition of a soil, that a mixture of organic matters and disintegrated rock is known as soil. Now we will further discuss that how these rocks are disintegrated and how these rocks are formed by the process of weathering. If we see about the next definition, the porous medium which is developed in the uppermost layer of Earth's crust. So basically, the upper one is the engineering definition, and the below one is, you can say that it is a biological definition of soil. Basically, what the porous medium which is developed in the uppermost layer of Earth's crust means a layer which is developed, which is present at the Earth's crust surface, at the top of the Earth's crust surface, which is a porous surface. Where porous means it can allow the passage of water. So water can pass through the soil, so it is a porous medium, and it is provided at the top of the Earth's crust, so it is referred as soil. So all these are the definitions of soil. First one is the engineering definition of soil, and second one we have referred the it is a biological definition of soil. Next, if we see that soils are formed by weathering of rocks. Soils are formed by weathering of rock. So basically, what is weathering? Weathering is the process of breaking down of rocks by physical and chemical process into smaller size. Means it is the breaking down process of the rocks. Means weathering is the, or in the other words we can say it as disintegration. It is basically the breaking down of the rocks into the smaller pieces. Now it can be by some physical process, and it can be by some mechanical process. Physical process means the change of temperature. The change of temperature will allow the rock structure to expand or to contract, and due to that expanding and shrinking process, there will be disintegration or weathering in the rock. But some chemicals, or some when the water is added, when the water is added in the rock, or water collides with the rock, then some mineral or any other chemical present in the water will react with the rock, and its structure changes, and it is also basically disintegration, and the rock convert into smaller pieces. So basically, weathering can be of two types: physical weathering and chemical weathering. Friends, next we discuss about the difference between physical weathering and chemical weathering. So let's see. It is physical weathering. First point, it is due to the expansion and contraction of rocks from the loss and gain of heat. So first of all, we are discussing that heat or temperature change basically affects the rock and rock structure, and due to which physical weathering occurs. The physical weathering process is the process of external any agent which changes the structure of the rock and disintegrates the rock. So basically, heat and temperature are also the effects. Now if the temperature rises, then also the weathering occurs, and if the temperature lowers, then also the weathering occurs because of the process of expansion and shrinking. Next, if we talk about simple point, no change in chemical composition means, as the name indicates, it is the physical weathering. It's the physical disintegration. Therefore, here there will be no chemical change in the composition or the structure of the rock. The rock will remain chemically as same as before. So it is only the process of breaking down of the rocks, breaking down of the large rock into the smaller pieces. It is basically the conversion of size of the particles of the rocks. Before they were a complete large rock structure, but after the physical weathering process, they were converted into the small pieces. So this is basically the physical weathering or disintegration. Next, we can see that we have to discuss some physical agents which become the basic cause of physical weathering. One of the most important physical agent is water. Water is an important physical agent. How? Let's suppose that we have this rock. It is a rock structure, and there can be some pores or the cracks. There can be some pores or cracks available present in the rock. So from these pores and cracks, the water can penetrate into the rock. Water can penetrate, enter into the rock structure, and it can, and after entering, it is in the rock structure, and then it can freeze and expand. Due to the temperature change externally, the entered water can freeze and then expand. So due to this change, the rock structure can break tremendously. So what is the basic concept? That when a water enters into the rock by these pores or these cracks, then it freezes there in the inside the rock and expands. When it expands, then the rock structure is damaged and the rock is converted into the smaller pieces. So this is the basically how the water can affect the physical weathering process. Next, if we talk about some other physical agents, other physical agents are wind, glacier ice. Wind can also disintegrate rocks. Similarly, glacier ice can also disintegrate rocks. Similarly, running water, steam, and river. Running water, when collides or strikes with the rocks, then it also physically damages or destruct or disintegrates the rock, and the physical weathering process occurs. So running water is also a very important physical agent, because it always, when it strikes with the rock, it changes the structure into smaller pieces. And ocean waves, similarly, you know that ocean waves are also very high velocity. When it strikes with any rock near the ocean, then it converts the whole piece of the rock into the smaller pieces. So this is all about our physical weathering. The last point is, if we see the examples, then sand and gravel are the examples of the physical weathering. Sand and gravels are produced due to the physical weathering of the rocks. So if we see any sand and gravel, which are our coarser material, then these are produced due to the process of physical weathering or physical disintegration. So next, friends, we talk about the chemical weathering. So let's see the first point. The original rock is transformed into new minerals by chemical reaction. So basically, in chemical weathering, the chemical structure changes, and due to the chemical reaction, we have changes, and we have new clay minerals, new minerals introduced due to the process of chemical reaction. So basically, chemical weathering is the result of chemical reaction. No physical agent is involved in this chemical weathering. There is change in chemical composition. As the name indicates, it will change the chemical composition of the whole rock structure. No, but here in the physical weathering, there will be no change, only the structure disintegrates. But here, more than the structure disintegration, here occurs the chemical change of the composition. If we talk about the examples, then clay is the best example of clay is the best example of the soil produced by chemical weathering. So basically, sand and gravel are the example of soil produced by physical weathering, and but clay is formed by the chemical weathering. So basically, what we talk about the reactions. Basically, the reactions, chemical reactions, are the cause of the chemical weathering. Here we can see one example of chemical reaction, in which you can see that water and carbon dioxide in the environment. Water and carbon dioxide in the environment reacts with each other to form carbonic acid. This is H2CO3 is a carbonic acid. This is a whole complete reaction. This is a whole complete reaction which occurs in the environment. That water and carbon dioxide reacts with carbonic acid, and it further disintegrates into hydrogen ion and HCO3. So basically, it is our first reaction. Now next, what happens, that these ions are generated in the these are the ions and molecules generated in the first reaction. It reacts with an orthoclase. Now what is orthoclase? Orthoclase is a mineral which form the igneous rock. Orthoclase is a feldspar mineral which form igneous rock. Now what you can say about feldspar mineral? It is potassium or sodium or calcium minerals which form igneous rocks. So basically, feldspar is a mineral family. Basically, feldspar is a large mineral family, among which there is a part orthoclase. Orthoclase is a, you can say, feldspar mineral. Basically, it is a mineral which compose the whole igneous rock. So due to the chemical weathering, orthoclase structure changes. Orthoclase chemical structure changes. How? it is shown in this reaction that orthoclase, first of all, orthoclase is a feldspar mineral which forms igneous rock. So here we consider it as a rock, and when it reacts with these 2H plus water, then its chemical structure changes and different minerals are produced. Different minerals, other minerals are produced, among which you can say that on the right side of the chemical reaction for SiO2, which you can also know that SiO2, silicon dioxide, is the name of silica, is a formula of silica. SiO2 is a formula of silica. So due to orthoclase reaction with 2H plus and water, hydrogen ions and water, what is produced? Silica is produced. And moreover, you can see that kaolinite, it is a clay mineral, it is also produced. So this is a formula of Al2Si2O5OH4. It is a basically chemical formula of a clay mineral named as kaolinite. So basically this chemical reaction exhibits that how the chemical weathering changes the structure of a rock and produces and forms new chemical minerals. Like in this case, orthoclase, when it reacts with this, then it forms silica, SiO2 and kaolinite, a clay mineral. So friends, next we discuss about the types of soil. There are different types of soil on the basis of transportation and their residence. So let's discuss. Basically, if we discuss, there are two types of soil. Where the basic classification is two types of soil. First is residual soil and second is transported soil. Let's discuss their definition. Residual soil is that soil located at the location of formation. Means it is the soil which is neither transported nor moved to anywhere. It is the soil which is deposited at the location of their formation. Means these are the soils which always remain there where they are produced or they are formed. So basically, as the residual soil is come from the word residence, they are always residual soil, they always remain there at the position of their formation. So that's the definition, located at the location of formation. But in case of transported soil, as the name indicates, they are transported from their parent location, means where they are formed, to a new location, transported from the parent location to any new location. So this is the basic difference between residual soil and transported soil, which is easy to understand. Next we discuss some other types of soil, which is among the transported soil and residual soil. So let's discuss. First of all, if we see that glacial soil, these are glacial soil is one type of soil, the soil formed by the transportation or melting of glaciers, also known as glacier drift. Means it is formed by when the ice melts or the water transports the soil, then due to that transportation, the glacial soils are formed. So basically it is what procedure, when the glacier melts, then the ice or the water emitting from the glacier transports the soil, and that soil is known as the glacial soil. And there is another name of glacial soil which is also known as glacier drift. So we can say glacial soil also as glacier drift, and it is basically formed by the melting of the glacier and then transported by the form of ice, by the agent as ice or an agent as water. So next friends, we will talk about the alluvial soils. As by definition, you can see that the soil transported by running water and deposited along the streams of the rivers is known as alluvial soil. So by definition, it means that these are the soils which are transported by the running water of river. Running water transports the soil and make it deposited at the bed stream of the river, and that soil is known as alluvial soil. And as it is deposited at the stream at the inside the bed stream of the river, therefore they are also known as riverine soils. So basically there is a very important point that alluvial soil are also known as riverine soil because these are transported by the running water and deposited along the stream. So basically there are 2 points, they are transported by the running water and deposited along the stream of the river and at the bed stream of the river. Therefore they are known as alluvial soil as well as riverine soil, related to the deposition in the rivers. So this is the concept of alluvial soils. Next we will discuss a simple concept about lacustrine soil. Simplest definition is a soil deposited at the bottom of the lake is known as lacustrine soil. So simply you can remember from lacustrine soil, L and the bottom of the lake. So basically these L can help you to remember the definition of lacustrine soil. You can say that soil deposited at the bottom of the lake. So in the lake, in the case of the lakes, the soil deposited at the bottom of the lakes, these soils are referred as our lacustrine soil. So in different areas there are different soils, different kinds of soil and their characteristics in the bottom of the lake, and these are also known as lacustrine soils. Next, we discuss another type, colluvial soil. Soil transported by a gravitational force is termed as colluvial soil. So basically, when the gravitational force is the main cause of the transportation of soil, then that soil is known as colluvial soil. So in the above, there are agents, but here there are there is a force, gravitational force. Gravitational force. How can we explain that? That let's suppose there is a hill or a mountainous surface, and from here our soil particle transports and falls down. So basically there is a gravitational fall, there is a fall due to the gravitational force. So the soil formed by due to this gravitational fall will be known as colluvial soil, because it is transported by gravitational force. And next, if we talk about the aeolian soil, then it is simple. The soil transported by wind is called as aeolian soil, such as loess. Now one thing to remember, that colluvial soil is also example as talus. So talus is a example of colluvial soil. It is a soil which is transported by the gravitational force, hence it is an example of colluvial soils. In case of aeolian soil, the soil transported by wind. Now you can remember that the wind or air, from the A of air and from the A of aeolian, you can take help to remember that A from air and A from aeolian soil. So it is easy to remember. And the soil transported by wind, so when the wind moves with high velocity, then the soil particles, you see, soil particles are transported or moved from a parent location to a new location. So basically wind or air is the main transporting agent in that case, and the soil formed by the transportation of wind or air is known as aeolian soil. So all these soils which are moved due to the wind pressure of air are known as aeolian soil. And one of their example is loess. Loess is also a type of soil which is moved by wind or transported, and it is an example of aeolian soil. Next, in the last, we discuss our marine soil, which are the simplest type of soil. They are formed by the deposition in seas. Basically, they are deposited in the sea, and they are deposited by the marine water. So basically, we can say that our sea soil is the marine soil. They are deposited in the soil, and they are deposited in the downstream, in the bedstream of the oceans and seas, and they are known as marine soil. So all these are types of soil, and basic types of soil are residual soil and transported soil. So in today's lecture, we discuss about the soil, its definition and its types. So hope guys you like this video and you understand the concept in this video. So if you like this video, then kindly subscribe my channel, and we will discuss in next video in next topic. Thank you, and Allah Hafiz.